Okay, so get ready to put all of your algebra knowledge and skills to work because I have an interesting little word problem here for you to solve. Matter of fact, this problem is not going to be so easy for most of you, but let me go ahead and read the problem. It is the following. How many ounces of 5% acid and 20% acid must be mixed to get 10 ounces of a solution that is 12.5% acid? Okay, now there is a lot going on in this problem, so you may want to pause the video and work through it. But if you can figure this out, go ahead and put your answer into the comment section. I'll show you the correct answer in just 1 second. Then, of course, I'm going to go through all the necessary steps to solve this problem. And this problem is what we call a mixture problem in algebra. It's a very typical, kind of classic type of problem. And if you are a student taking first or second year algebra, college algebra, pre-calculus, courses like this, you must know how to solve these type of problems. So you definitely want to pay attention. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, so we're going to obviously study this question, more than a few times, but just a quick rehash. What's going on here? Well, we have 5% acid. Okay, we don't know how much to use of this particular acid. We're going to combine it with 20% acid, and our goal here is to get a mixture that is 12.5% acid, and we want 10 ounces of this particular mixture. So we want to know how many ounces of this mixture and how many ounces of the 5% and how many ounces of 20% do we need to use to combine this to get 10 ounces so we can get a mixture that is 12.5% acid. So if you are confused, I get that. But as we go through the solution, I promise you, you will understand this. But let's go ahead and take a look at the answer. The answer is the following. Okay, so we need 5 ounces of the 5% solution combined with 5 ounces of the 20% solution. That is what is required to get 10 ounces of a 12.5% acid solution. Now, some of you might be saying, "Oh my goodness, Mr. YouTube Math Man, I'm totally lost. This is why I don't like math. This is so confusing." Well, it's confusing if you don't understand the problem. Now that's clearly obvious. You're like, well, obviously, Mr. YouTube Math Man, I don't understand. Well, we need to kind of get you to understand, and the only way to understand anything is to break it down in its kind of component parts and the required skills. So we need to be patient here. These type of problems tend to give students a bit of difficulty, but once you've done a few, you can do pretty much most of these type of mixture problems. And again, this is something that you definitely need to know. But if you got this right, we must celebrate by giving you a nice little happy face and A plus plus. Matter of fact, I think I'm going to give you 200% and multiple stars. A matter of fact, if you were in my algebra class, I just might say, you know what, take the rest of the year off. You're definitely a math superstar. I don't know how you got so smart in algebra. Maybe you're watching that guy on YouTube. I have no idea. Okay, but all fun and jokes aside, let's go ahead and get into the solution because there is a lot to cover. And as we go through all the steps here, if you don't know a particular skill, an algebra skill, I'll give you some suggestions so you can really, practice and learn these skills because this is essential for those of you that are students. All right, so first things first, here is our problem. So with any math word problem, whether it's algebra, geometry, it doesn't make a difference. You need to read the problem at least 3 times. Now, there's a lot of information here, and just to kind of conceptualize what's going on, we need to have some sort of model. We need to want to visualize it because we have 5% acid, 20% acid. We're looking for how many ounces of each of these, and we want to create some sort of mixture that is 10 ounces, and the mixture is 12.5% acid. So this can be certainly confusing. So you always want to construct a model of a situation. It's very, very helpful. And, there's different ways to do this, but effectively, this is what's going on. Okay, so we have 5% acid over here and 20% acid over here. We want to combine these two. We want to mix them in some manner. So we end up with 10 ounces of a mixture that is 12.5% acid. So the question is, how many ounces of the 5% and how many ounces of the 20% should we use, right? Now, if we use too many ounces of 20%, well, think about it. Then if we're going to dilute down the 5%, and again, if we use too much of this, it's really going to increase the percent of acid, right? That kind of makes sense. So, in other words, if we had here is our 5%, we only put a little bit of the 5% in, and then the majority of here was the 20%, maybe this mixture would be like 19% acid. So, of course, there is some sort of balance here. And we're going to have to figure out, well, exactly how much of this do we use with this to make 10 ounces of this, which, of course, is 12.5% acid. So that's effectively the question. And what we need to observe here is how many unknown values are in this question. Okay, so let's go back to the question. It says how many ounces of the 5% and 20%. So how many unknown values are we looking for? Well, we're actually looking for two values that we don't know. Okay, there's two unknown values, this one and this one. So in terms of algebra, the amount of unknowns that you have is typically going to be the amount of variables that we need to use. So we might be thinking in terms of using two variables here. So maybe we'll let x equal the amount of ounces for the 5% solution and y the amount of ounces for the 20% solution. Okay, so if we have two variables, x and y, well, then you need to start thinking in terms of a system. Okay, so just real quick here. So if I have one variable I'm solving for, typically all you need is just one equation. So for example, 2x is equal to 10. Here's one equation. I could solve for one variable here, a nice linear equation. Just divide both sides of the equation by 2. But if I have an equation that has both x and y, or two variables, well, let's suppose I have one equation. That's not enough. One equation is not enough to solve for two variables. So typically, you're going to need, as a general rule in mathematics, you're going to need the number of variables you're trying to solve for. That's the number of equations you need. So we need another equation, something like 2x minus 3y is equal to 11. Here, we need two equations because we have two variables we're looking for. Okay, so again, this is why you need strong algebra skills here. And indeed, this is going to be a problem that requires a system, okay, a system of equations, and to be precise, a system of two variable linear equations. Now, if you're like, boy, this is a lot, well, again, this is stuff that you should be learning in your first year algebra course. But again, a lot of students struggle with this stuff, but you're going to be an expert when you take your test or exam. Your teacher is going to be so impressed that, boy, were able to actually solve these mixture problems. Okay, so let's go ahead and get into it right now. So let's go back up here. Let's define x. Let x, we're going to let x equal the number of ounces for the 5% solution, and we'll let the variable y equal the number of ounces for the 20% solution. So let's go ahead and define that right here. So we'll let x equal the number of ounces for the 5% solution and let y equal the number of ounces for the 20% solution, because we're going to get, although the answer here is the same, right? We have 5 ounces of each. You could have ended up with different amounts. So we want to use different variables. We can't have x equal the number of ounces for the 5% solution and x equal the number of ounces for the 20% solution. We have to define these unknown values with different variables. Okay, so that's the first thing that we're going to do. Now, the second thing is very common for mixture problems. You want to set up a table, okay? So let me go ahead and walk you through the table. Of course, I already kind of constructed this, but this is what you want to do. Okay, so what kind of solutions do we have here? Well, we have a 5% solution. we have a 20% solution. Of course, we're talking about acid here. And of course, we have a 12.5% solution. So there's three types of solutions that we have. Now, how many ounces of these respective solutions do we have? Well, the 5% solution, we don't know, okay? But whatever it is, it's going to be X ounces, right? Because we already defined that. We have Y ounces of the 20% solution, and we know from the problem that we want 10 ounces of the 12.5% solution. Okay, so that is the ounces in the solution. So how many ounces of acid do we actually have? So this is going to be key here. So the amount of acid, ounces of acid, is if we have 5%, and let's say you have 100 ounces, well, how much of that is acid? Well, if we take 5% and multiply it by the total ounces of that solution, you're just going to change this percent to a decimal. So that'll be 0.05 times how many total ounces are in that solution. And this is the amount of acid you will have, 0.05x. Okay, so you need to understand that, right? So here, this is the amount of acid you have. So 5% solution means out of 100 ounces, 5 ounces are acid. So now we're going to go ahead and define how much actual acid we have. Okay, so 20 ounces of this particular solution, a 20% acid solution, and we have Y ounces. How much of that is actually acid? We're going to change the 20% to a decimal, so that's 0.20 times Y. And then for a 12.5% solution of acid, and we have 10 ounces, how much of this is acid? Well, again, we're going to change this 12.5 to a decimal, the percent to a decimal, so that's 0.125 times 10 ounces. Okay, so this is what we need to do. We need to kind of construct all this information, and now we're going to build some equations because we have two variables here, and we can't solve for these two variables unless we can construct two unique separate equations that involve both of these variables because we want to set up a linear system here. Okay, so let's go to do that right now. So here we know that x plus y, this is the number of ounces that we're going to use for the 5%, right? So whatever our 5% ounces is plus our 20% ounces are going to be, we know that the total, we can't use too much of the 5% or too much of the 20% because the total amount's got to be 10%. So let's go back to our table here. Remember, this is the ounces of solution. This is how much we're going to be mixing together. So we're going to be mixing together so much of this plus so much of that, but the total is going to be 10, all right? So you got to really be paying attention to these equations. And our second equation is the amount of acid, okay? So however, how much ounces that we're going to be using of the 5%, this is the amount of acid that you're going to have, right? So our other mixture, our 20% mixture, this is the amount of acid it's going to have, but we know that the total amount of acid together is going to be equivalent to that 12.5% acid of this 10-ounce solution. Okay, so you can't have, this is the amount of acid here plus this amount of acid. It's got to be equal to this amount of acid right there. All right, now this could be confusing, and if it is, don't feel bad because these problems, again, if you are new to them, are a little bit confusing. But once you understand them, like then, as I was saying earlier, you'll understand how to do other type of mixture problems. But effectively, what we have here is one equation, x plus y is equal to 10, x plus y is equal to 10. This is one equation that involves these two variables, and this is another equation that involves the two variables x and y. So what we have here is a lovely linear system. And of course, we're going to have to clean this up. And let's go ahead and start working on solving for x and y. Okay, so first things first. So you need to understand how to solve linear systems. Now, if you don't understand how to solve a system by using the substitution method or elimination method, there's other techniques as well. Well, then you probably want to, pause this video and just make a note, be like, okay, I need to learn systems. So for those of you that are looking at this, you're like, yes, indeed, Mr. YouTube Math Man, this is what I need to learn. I'm going to direct you towards my Algebra 1 course or my Algebra 2 or maybe even my pre-calculus course, but this is stuff that you should be able to do in Algebra 1. So take a look at my Algebra 1 or Algebra 2 courses. You can find links to those in the description. I give you full instruction and multiple examples, step-by-step prompts on all this stuff. So you need to understand all the skills here or you're not going to be able to solve these type of problems. Okay, so we're going to be focusing here on solving this system, different techniques you can use. But the first thing I'm thinking about is like, you know what? I have 0.05 and 0.20 and 0.125. Let me just go ahead and get rid of these decimals. And we could get rid of these decimals or make these decimals, kind of disappear by multiplying them by 100. Okay, so you don't have to do this, but I'm going to do this. So we're going to take 100 and we're going to multiply the second equation by 100 just to make the system look a little bit better. Again, this is not required. It's just a nice step. And again, there's different techniques and methods you can use to solve for x and y. So if you solve this problem, but you took a different approach, that is fantastic. Okay, so I'm going to go ahead and multiply this second equation by 100, but I'm going to go ahead and pause this video before I show you the results of that because I need your support. Could you consider subscribing to my channel? Okay, well, if you're into this video and you're like, you know what, I'm just going to subscribe so this guy can hurry up and get back to the problem. Well, you know what? I think that is a fair trade-off. If you're going to subscribe, make sure to hit that notification bell as well. As you can tell on my videos or what I post on YouTube, I really try to teach thoroughly. Okay, I walk through. I take one problem and I really try to explain it because most people, need a full comprehensive explanation. And if you're frustrated in math, if you're having difficulty, one or two things are happening. One, you're not getting the kind of instruction that fully explains things, or two, you're not maybe trying hard enough. So, if you don't have access to instruction, okay, I would like to be your math teacher. So definitely hit that subscribe button. It basically means, or I feel like I've just gained a new student. Okay, so let's get back to this problem here. So when I multiply this second equation by 100, and you're allowed to do this in systems, again, if you don't understand linear systems, then you're going to have to do some work beyond this video. But I'm just doing this so we can get rid of these decimals, and the result of multiplying this equation by 100. And remember, I can multiply anything. I could take this equation in systems and multiply it by 2. Here I would end up with 2x plus 2y is equal to 20. You could do that. Is there any value to doing that? Well, you have to ask yourself, but you are allowed to do that. So there's nothing wrong with me multiplying each terms of this equation by 100. Okay, but the goal here is to get rid of the decimals. So now I'm left with this lovely system right here. X plus y is equal to 10. And 5x plus 20y is equal to 125. Okay, so all different sorts of ways to solve this system. What I'm going to be doing here is using the elimination method. So I have a 5x right here. I'm like, you know what? It would be nice if I had a negative 5x right there, because if I combine these two, I get rid of the x variable. Okay, I'm just left with y's, and that's what you have to do when you're solving linear systems, is you need to get rid of one of the variables. You either do that through elimination or linear combination or substitution. Okay, again, this is really a matter of preference, but you do definitely need to know both techniques. Okay, so I'm going to go ahead and multiply this top equation by negative 5 so I can get a negative 5 right here. So I'm going to have to multiply each term by negative 5. Okay, so negative 5 times x is what? Well, let me go ahead and show you the results. That's negative 5x. Negative 5 times y is negative 5y. Negative 5 times 10 is negative 50. Okay, so at this time, I have these two variables here, negative 5x and 5x. If I combine these, the x's go away, and I'm left with only y's, and that's exactly why I multiplied this top equation by negative 5. So let's go ahead and do what we call a linear combination, so we can kind of smash these two equations into one. So negative 5x plus 5x is 0, okay? Negative 5y plus 20y is 15y, and negative 50 plus a positive 125 is 75. Okay, so now I'm left with one equation in one variable. So 15y is equal to 75. All I have to do is divide the equation, both sides of the equation by 15, and I get y is equal to 5. Okay, so that is pretty awesome. Now, what do we do from there? Well, you have all different sorts of options. To solve for x, we can go back to any one of the equations in our system. Let's take the easiest equation. Remember, we had x plus y is equal to 10. Well, if y is equal to 5, all I have to do is replace this y and solve for x, right? So I'm going to replace this y with 5. So x plus 5 is equal to 10. Well, here, obviously, x is equal to 10. So y is equal to 5 and x is equal to 5. But what does that mean? Well, we got to go back to our variables when we set up this problem. X was the number of ounces for the 5% solution, and Y is the number of ounces for the 20% solution. So the bottom line here is that we need 5 ounces of the 5% solution combined with 5 ounces of the 20% solution. That's what's required to get 10 ounces, right? Because we got 5 ounces and 5 ounces, we're going to get 10 ounces. But the percent of acid is what we want, right? We're going to get 12.5% acid solution. All right, so these type of problems again are not so easy. They're a little bit confusing for sure, but again, once you learn how to do one, okay, a type of mixture problem, then you should be pretty good to go with other types, okay? But you certainly can't solve these problems if you don't understand how to solve a system. And for those of you that are math students, you're taking Algebra 1, College Algebra, Algebra 2, any kind of first or second year algebra, you must know how to solve mixture word problems. Okay, so hopefully this video helps you out. And if that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.